This is Abhishek Singh, Assistant Professor at Engineering College, Banswara, Rajasthan. So welcome to our channel, TEQIP Faculties. Here we have started bridge courses for first year students under the initiative Let's Bridge the Gap. Okay, so I am here to teach the basic electrical engineering, which is one of the most important subject in first year. So I'll go with first DC part, then some AC part, and then some power converters. Okay, so today I'll start the basic concept of electricity, the very basic quantities of electricity. So when we talk about electricity, the first thing which comes in our mind is the basic quantity, electric charge. Okay, we all experience this charge in our daily life, like while we are removing our woolens, while walking on carpets. Okay, so what's basically the charge is? Here we'll discuss one by one. First we'll discuss what exactly the charge is. So charge is an electrical property of atomic particles of which matter consists, measured in coulomb. Okay, so the matters made up of some basic building block, that is atom, and which consists electron, proton and neutron. We all know this. The electron has negative charge and the proton has positive charge on it with same magnitude, and both the electron and proton with same magnitude leaves the atom neutral. Okay, so the charge on electron is negative and is the magnitude of 1.602 into 10 to the power minus 19 coulomb. Okay, so we'll discuss some basic properties of charge, or basic things about charge. The first is that this coulomb is a very large unit for the charge. Okay, coulomb is very large unit for charge. Why? Because in one coulomb we have 6.24 into 10 to the power 18 electrons of charge. Okay, so in laboratory, in practical values of charge will take in picocoulomb, nanocoulomb or microcoulomb. Okay, and the second thing, the very basic thing, is the law of conservation of charge. Law of conservation of charge means the charge can neither be created nor be destroyed. Means the algebraic sum of charge in a particular system will remain same. Okay, so these are some basic things about charge. We all know if we apply a battery across a conductor material, the positive charge will flow towards negative end and the negative charge will flow towards positive end. So conventionally we take the direction of flow of positive charge as a direction of current. Okay, so next in line we'll discuss the next very basic quantity, that is electrical current. Okay, this current. So what current is? Electric current is the time rate of change of charge measured in ampere. So we'll define it as I is equal to TQ by dt measured in ampere or coulomb per second. Okay, or in other way we can define that amount of charge transfer or enter in a particular element between time t0 to t is given by, so charge transfer between time t0 to t in an element, क्या लिख सकते हैं, q is equal to integration t0 to t I dt. Okay, coulomb. ठीक है. Okay, so this current I can be DC, that is direct current, or it can be an AC current, that is alternating current. So how we define DC current? So the DC current, the current which flows in only one direction, we can call it as a DC current. So current which flows in only one direction, Okay, so it can be constant or it can be time varying also, but it flows in only one direction. In many books you will see the definition of DC current that it is a constant current. The current that is constant is called DC current, but it's not like that. The DC current is the current which flows in only one direction. Okay, so it can be constant or it can be time varying. Like if we have current like this, so it is constant and flowing in one direction only, so it is DC. And if we have current like this, it is also a DC current only, but time varying. Okay, so it can be constant, or time varying, Okay, so make it clear here. AC, next is AC, alternating current. This is flows in both direction, positive and negative, flows in both direction. Okay, and time varying. So please make this terms clear. DC and AC. DC, it is flows in one direction, it can be constant or time varying. Okay, next we'll discuss. Okay, next let's take a question, take a numerical. We have just studied some basic formulas of charge and current. So how some numericals we face based on these formula. Here is one. The current flowing through an element is I, that is 4 ampere in time 0 to 1 second and 4t ampere at time greater than 1 second. So calculate the charge entering the element from 0 to 2 second. Okay, so we have just studied the current charge transfer in the element between time t0 to t. So we can apply this Q is equal to time 0 to 2 I dt. Okay, but between time 0 to 2 the current is not same. Current is 4 ampere for 0 to 1 second and it is 4t for t greater than 1. So we'll break it in intervals like 0 to 1. 0 to 1 our current is 4, so 4 dt, and plus 1 to 2. 1 to 2 our current is 4t dt. Okay, so I will integrate it 4 into t plus we'll put the limit here, plus 4 t square by 2. We'll also put the limit here to 1, and we'll solve it, and we'll get that this is 4 and this is 6 and is equal to 10 coulomb. Okay, so these are basic numericals which we can face based on this basic formulas. Okay, so let's move for voltage. So what is voltage? Voltage or potential difference is the energy required to move a unit charge from a reference point to another point. Okay, so if we have to move a charge in a particular element, a conductor, so we have to apply some force or some energy is required here. So if we apply some force like this battery, then the charge moves and the current flows. Okay, so we'll define V, voltage, as energy required, that is W, to move a particular charge from one point to another point. Okay, or you can say it volt, the unit should be volt or joule per coulomb. Okay, dw by dq. Okay, so if we have element here with the polarity like this is point A, B, plus minus, potential difference is VAB. So we can say the node A or point A is VAB voltage, VAB volt higher than point B. Okay, so here VAB would be equal to minus of VBA. Okay, so this is same only. Okay, so if we move from lower potential to higher potential, it is voltage rise, and if we move from higher potential to lower potential, it is voltage drop. Okay, so we'll discuss it later when we discuss the power and all. Okay, so let's move to the power. Okay, so what is power? Power is the time rate of expending or absorbing energy measured in watt. Okay, that means P is equal to time rate of change of energy, that is dW by dt. So if we multiply and divide the charge here, dW by dq and dq by dt, what we'll get, this dW by dq is voltage only, and this dq by dt is current, we have discussed earlier. So this V and this will be I. So here we have a formula for power is V into I also. Okay, it is in watt. Okay, so conventionally if we have power positive, it means the element is absorbing power. It means the element is absorbing power. Okay, or if we have power negative, it means element is delivering power or supplying power. Okay, so let's talk about the convention, sign convention. If we have element with polarity like plus minus, and if we have some V volt here and the current entering in positive terminal, then we'll call power is equal to Vi plus Vi, and if it is entering in negative terminal like this, P voltage, and if it is current is entering in negative terminal, then we'll say P is equal to minus Vi. Okay, so generally if the current enters in a negative terminal, then the element will be delivering the power, and if current enters in positive terminal, the element is absorbing the power. Okay, so these things should be clear. Okay, so one thing we have to remember, if while calculating our power comes positive, and the question is ki what is the amount of power the element is delivering. Okay, our answer is positive, and the question is what is the amount of power element is delivering. Then we have to answer negative. We have to answer the negative one, because if current enters in a positive terminal, we all know that the element is absorbing power. But if the question is that what is the amount of power the element is delivering, then it will definitely be negative. Okay, so we'll discuss the question later, that will clear you. Okay, so next discuss energy. So what is energy? Energy is the capacity to do work measured in joule. So E is equal to capacity to do work. So you can define it as a P dt. Okay, capacity to do work, or Vi dt. Okay, this is in joule. Okay, or watt second. Vi is the watt, it is second. Okay, so what in 1 watt second means 1 joule. So if we write it in watt hour, then there is a 3600 joule. Okay, in 1 kilowatt hour there is a 3.6 joule. This 1 kilowatt hour is important, because in 1 kilowatt hour means 1 unit of energy consumed. We see this unit thing in our electricity bill. So this 1 unit means 1 kilowatt hour energy. Okay, fine. So let's take a question. What is this? An energy source forces a constant current of 2 ampere for 10 seconds to flow through a light bulb. Okay, if 2.3 kilojoule is given off in the form of light or heat energy, calculate the voltage drop across the bulb. So we have studied the voltage, formula of voltage, that energy required to move a charge. Okay, here we have energy of 2.3 kilojoule, and the thing we require is the charge. Okay, so how can we calculate charge? Here we have the current given, that is 2 ampere for 10 seconds. Okay, so the charge is clear. Q is I into T. This means 2 into 10, it is 20 coulomb. Okay, so we can calculate V, that is W by Q. W is 2.3 into 10 to the power 3 divided by Q, that is 20 coulomb. Okay, so these are the basic numericals based on basic formulas only. Okay, so next we will discuss some basic circuit elements. We move towards the circuit element. Circuit element. Okay. So basic circuit element, we first discuss about the voltage sources or current sources, basic sources. Okay. So first we'll discuss about the ideal independent source. What is it? An ideal independent source is an active element that provides a specified voltage or current that is completely independent of other circuit element. Means ये जो sources हैं आपके, these sources ये सर्किट के किसी भी और ब्रांच के वोल्टेज या करंट है किसी पे भी डिपेंड नहीं करते, इनकी वैल्यू फिक्स होती है. ओके. डिनोट करते हैं जनरली हम वोल्टेज सोर्स को इस तरह से, इंडिपेंडेंट वोल्टेज सोर्स को कुछ भी वैल्यू और करंट सोर्स को कुछ इस तरह से चलिए डिनोट करते हैं. ठीक है. इंडिपेंडेंट सोर्स मीन्स इनकी वैल्यू अगर 20 वोल्ट का है वोल्टेज सोर्स तो उतना ही रहेगा, किसी पे डिपेंड नहीं होगी. और ये कुछ एम्पियर का करंट सोर्स है तो उतना ही रहेगा, उस पर डिपेंड नहीं करेगा. हम आइडियल की बात कर रहे हैं, अभी प्रैक्टिकल की भी बात करेंगे जब हम थोड़ा सा रेजिस्टेंस और इसके बारे में पढ़ लेंगे. ठीक है. तो ये हमारे सोर्स हैं जो कि बिल्कुल इंडिपेंडेंट है, इनकी वैल्यू हमारी कभी चेंज नहीं होगी. ठीक है. नेक्स्ट, आइडियल डिपेंडेंट सोर्स और कंट्रोल सोर्स. व्हाट इज दिस? Is an active element in which the source quantity is controlled by another voltage or current source. So we are saying it again and again, this active element. So what is this active element? The element which produce energy. Okay, so we can define active element also, the element which produce energy. And what is passive element? The element which dissipate energy or store energy. Okay, which cannot generate energy. Okay, so element that can generate energy, these are active element. Generate energy. Okay, so let's talk about the dependent source. Okay. So what is dependent source? It depends on the value of it depends on another voltage or current. Okay. We denote it generally by a rectangular sign like this. Means if we have voltage source here, its value would be like this, or it would be like this. It means it is a voltage source, but its value depends on the current of another circuit element, another element of the same circuit. And here it is a voltage source, but its value depends on the voltage of another element of the circuit. So this one we can call it current control voltage source, because it is a voltage source but controlled by the current of some different element. Okay. And this one we can call it voltage control voltage source. Okay. Same way we have a current source also. Here if we have value like this, we can call it what? This is current source and controlled by current of different element. So we can call it current control current source. And like this, if we have current source with value xv, we can call it voltage control current source. So these are the four basic type of dependent source, which values depends on the different circuit elements, voltage and current. Okay. So let's take an example for calculating power. Okay, we'll understand better. Okay, here we have to calculate power indicated at each element, that is P1 here, P2, P3, P4, P5 here also. let's say it's P5. Okay, so what is the power P1? Here 9 ampere entering in negative terminal only, voltage is 5 volt, so we can call it minus 9 into 5, that is minus 45 P1. Okay, what is P2? P2 is the current 9 ampere entering in positive terminal, voltage is 2, we can call it 9 into 2, that is 18 watt, 45 watt. What about P3? It's a P3. Okay, no need of P5, it's P3. So what is P3? The voltage source, this is a voltage source which have a value 0.6 I. Okay, so voltage value is 0.6 I. I is this current, that is 5 ampere. So what's the value of voltage? 0.6 into 5 means 3 volt. Okay, 0.6 into 5 is 3 volt. So voltage is 3 volt and current entering in positive direction, it is 4 ampere. So the power is 12 watt. Okay, here in P4 current 5 ampere entering in positive direction, so P4 is equal to 3 into 5, it is 15 watt. So it means this P1 with minus 45 watt, it is actually delivering power, and all other elements, the P2, P3, P4 are absorbing the power. Okay. Okay. So let's now talk about some another basic elements. The first we will discuss about the resistor. Okay, so what is a resistor? It is a passive element, which dissipates power. Passive elements which dissipates power or absorb power, which dissipates power or energy. Okay, and defined as R is equal to rho L by A, where rho is the resistivity, R is what? R is resistance. The behavior of resistor is to resist the current. So R resistance, we can call it resistance. So behavior of resistor is to resist the flow of current. Okay, its behavior is to resist the flow of current, and this phenomena we call generally a resistance. So R is the resistance and can be defined as rho L by A, where rho is resistivity of the material. Okay, L is the length of the conductor and A is the cross section area of the conductor. Okay, so this resistance depends on the dimension of the conductor. Okay, so resistivity, you should remember that it's a property of material. So it does not depend on the dimension of the conductor. So resistivity is the property of material. So it's a property of material. Okay, so resistance can be linear and can be non-linear also. Non-linear, like in diode and transistors, we have a non-linear resistor. So in this course we'll discuss about the linear one only. Okay, so which follows the Ohm's law, we'll discuss later. Okay, so the next circuit element we're going to discuss is capacitor. Okay, Now we'll discuss capacitor. Okay, so what is capacitor? Capacitor is a passive element which store energy, which stores energy in electrostatic form, in electrostatic field. Okay, so what is capacitor? It's basically two parallel plates filled with a dielectric. Basically two parallel plates filled with some dielectrics. Okay, so when we applied a voltage source to the plate, suppose we apply a voltage source to the plate V, then the charge will be deposited on the two plates. Let's say it's a plus Q and here it's a minus Q. Okay, so when we apply the voltage, the charge will be deposited on the parallel plates, and this amount of charge stored or deposited on plate will be proportional to the applied voltage, and you can say Q is equal to CV, where this proportionality constant is our capacitance. Okay, so we can define capacitance as the charge stored is the ratio of capacitance is the ratio of charge stored to the applied voltage. C is equal to Q by V, measured in farad. The practical values of capacitance is generally microfarad, picofarad, nanofarad. Okay, so although this capacitance C is the ratio of Q and V, but it does not depend on Q and V, and it depends on the dimensions of the parallel plate capacitor. So C is equal to epsilon A by T. This epsilon is the permittivity of the system, and you can write it at epsilon naught epsilon R A by D, where epsilon naught is absolute permeability, epsilon R is relative permeability, that depends on the material, the dielectric material. A is the cross section of plate and D is the distance between plate. Okay, A is the cross section area of plate. Okay, so if we want to establish a voltage current relationship for capacitance, so we can differentiate this equation. So what we get, dq by dt is equal to C dV by dt. Okay, this dq by dt, we know it's a current only. The current capacitance is C dV by dt. So from here we can conclude a sentence that the capacitor does not allow sudden change in voltage. Why? Because if you see this formula, if you want to change the voltage suddenly, means in no time means t is equal to 0. If in t is equal to 0 we want to change this voltage, we have to apply an infinite current, which is not possible, not practical. So the capacitor does not allow sudden change in voltage. And next thing, I is equal to C dV by dt. Okay, so if you apply a DC voltage, then dV by dt will be equal to 0, so current will be 0. So you can say capacitor block DC. Okay, that blocks DC current. Although the voltage, if we apply DC voltage, the charge will store, but it will block the flow of DC current. Okay, so if we want to write the voltage equation, we can write it like V is equal to 1 by C I dt plus V naught. Means these equations indicate that capacitor has a memory. Okay, so current and voltage in capacitor depends upon the initial voltage or initial current in the capacitor. Okay, now let's talk about other element, that is inductor. So what is inductor? Inductor is also a passive element, which stores energy in the form of magnetic field. Okay, and stores energy. Okay, now inductor is basically a coil. So if we allow a current I to flow in a coil, then a voltage, there is a voltage across a coil, and this voltage V will be proportional to the rate of change of this current, that is di by dt, and this will equal to V is equal to L di by dt, and this L is our inductance. Result in Henry. Okay, so inductance can be linear and non-linear. Capacitance we have discussed earlier, it also can be linear and non-linear, but in this course we will discuss the linear one only. Okay, so with this equation we can here also conclude that inductor does not allow sudden change in current. Why? Because if we want to change current suddenly, like in no time, if t is equal to 0, we have to apply an infinite voltage again, so which is not practical, not possible. Okay, and with this equation only, if the current is constant, then di by dt will be 0 definitely, and then voltage will be 0. It means short circuit. So the inductor act as a short circuit to DC. Okay, it will act as a short circuit to DC. So if we write a current equation, I, you can write it like I is equal to 1 by L V dt plus I naught. So this equation shows that inductor also has memory, depends on initial value of current in the inductor. Okay, so inductor 2 can be linear or non-linear. Okay, so here we'll study linear one only. Okay, so let's talk about the energy stored by this capacitor and inductor. Energy stored. So we all know energy, we have seen the formula of energy is P dt. Okay, so if we talk about, when we talk about capacitor, energy E equal to P, that is VI dt, and we all know in capacitor I is equal to C dV by dt, dt cancel, C V dV, and it will come half CV square. Okay, so energy stored in capacitor will be half CV square. Same way, if we talk about energy stored in inductor, we can derive from same formula, like E is equal to VI dt. For inductor, we all know V is equal to L di by dt I dt, dt cancel, L di I di, will integrate it and we got half Li square. So energy stored in inductor is half Li square, and energy stored in capacitor is half CV square. Capacitor half CV square. Okay, so these are some basic circuit elements. In the next lecture we will discuss some basic laws which will apply while solving the circuit. Some basic law like Ohm's law, Kirchhoff's law, and some solving methods like nodal and mesh analysis. Okay, thank you.